So finally, we are coming to the phase where C13 chemical shift predictions. For example, if you are exploring a large set of chemical shift data and you need to allow the development of empirical rules, but so in this, the prediction of the chemical shift values for most commonly encountered situations you can do, but it is slightly difficult to analyze the things. So what are the different predictions and very well predictions you can see that is really difficult, but there is a possibility to get the dependent values and then comparison values to remember to remember the chemical shift values in the C13 number. If you take the proton number, it is slightly different because slightly easy because the scale is very less. It starts from 0 and then it ends hardly with the 14. So 14 always you will not see any 14. So you will see with the 10 only. So this scale 0 to 10, the scale you can remember easily, but here we are having 0 to 200 or 300 also sometimes. So how you will remember? It is little difficult, but comparison and estimation based on the comparison and these things will be helpful for you. So we will see how it deviates and what are the values you can remember, and with using that values how you will estimate it. And for benzene, all the benzene you can see a single peak without any substrate. You can see a single peak, and this can be added to these value substrate increments. So which depend on the chemical nature. While calculating, so there is a procedure to calculate the delta values in C13, but in CSR they are not asking, so I'm going to skip that. But what are the different values are there, temperature values, I'm going to give the information. But how to calculate? This is if you are in yeah, only for academic things, academic examinations, they are asking how to calculate, like in H1 university. So, but in CSR examinations, they are not allowed you to remember all those things, and then they are not going to ask you how to calculate. In previously, they used to ask some 1 decade ago, but nowadays, I could not see any question on that. So you can just forget about that, no problem. And here you can, so there is some methods how you will calculate that thing. So with using the single base and then you can add the increments of the substance based on that. So chemical nature, you will get the substance effects on that, and then you will add the values to that. And finally, you can predict the chemical shape, how much that particular carbon is going to have in the C. So that is also one method is there. That is also one method is there. So the carbon atoms are substituted with it. So you can see that and then you can develop the one. So they're very small. Okay, I'm going to give information, but don't worry about this. Please don't try to buy hard this. It's not going to be useful for you in CSR examination. If you are having any substance on the aromatic systems, you'll see that. So if it is this is the these are the different substituents and these are the different positions. Hope you understand what is the position and then where it will be. So if you have this is the ipso position, and then this is ortho position, this is meta position, this is para position. I think you know about this. If you have any value here, any substrate like this CS3 is there, if it is in a ipso position, you can add 8.9 to that, ortho 0.7, meta minus 0.1, para minus 2.9. So initial ring value is 128.7, and you can add if you are having one group at CS3 in ipso position, so you will add that 8.9. If you are having one group NO2 group at the meta position, you take the NO2 at the meta position. This is adding up to 0.8, so totally 139. So that means you are, if you have a benzene ring like this with a substitution CS3 at this position and then NO2 at this position, so you are going to get the peak. So at 138.9 ppm like that. So like if you are having C1 carbon, this is for the C1 carbon, and then if you are looking for the C2 carbon, yes, here you are going to see the C2 carbon. So this is the addition you have to add, and then you are going to get the 124.1. Like that, there is a small method, so you can predict the chemical shifts. And this is not useful for your CSR. Okay. And so this is one example, and you can predict the chemical shift values, which is calculated and then observed. You can get it, yeah, with using the methods. And for the alkyl groups also, you will have a chance to predict based on the X values. The base value is the base value will be there. First, you have to use the base value. So if you have the base, if you know what is the base value, then you can start adding these groups. If it is there at alpha position, how you will add. If it is there at beta position, how you will add, and then gamma position you will add. So this is the terminal groups, and then this is internal groups. Let's see. Based on that, you will have a, so this is internal group. If you have the internal group at base, internal, and terminal groups if it is there in this place. So if you want to calculate the alpha carbon, so how much it will predict. If you want to calculate the beta carbon chemical shift value, for example, if it is chlorine, so beta carbon for base value you have to add the 9. Like that, you can predict the alkyl group chemical shift values also. You can Yeah, so we have some important information. So you can predict that with using the values. You can calculate usually. So, and now we'll see another important concept here. So this is also there in the NOE, nuclear overhauser enhancement. This NOE is there in all the NMR experiments. You will see the NOE effect and previous slide. Yeah, these are not asking in CS. You don't have to worry about this. Just for the sake that okay, there is a method available. That's why I thought of showing one slide about that. But it is not going to use.